This is my beginning algebra course. Today we're going to continue to factor algebraic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by factoring trinomials of the form ax to the fourth power plus bx squared plus c. And this is just a special type of factoring. You're not going to see these types of problems a lot, but you will see them. It's pretty much a guarantee that you'll see these at least once in your math education. And this also helps us to review previous concepts that we learned in the last couple classes. So this is the first thing we're going to do today. So let's try number one. You can just consider this to be a quadratic expression, even though it doesn't look like a quadratic because you have a fourth power and a second power. Usually you would have a second power here and a first power here. So we're going to put two pairs of parentheses like we did in the last classes. And what two numbers multiply to 40 and add up to 13? So this is the same type of problem. But instead of writing x's here, we're going to write x squared. And then, of course, it would be 5 and 8. Because 5 times 8 is 40, and 5 plus 8 is 13. So that is the answer. Now, if you FOIL that out, x to the second times x to the second is x to the fourth. And the outside terms, we get 8x squared. Inside terms, we get 5x squared. And last terms, we get 40. Add those middle terms, and you get 13x squared. And you can see we go back to this expression. So again, this is just a special case when you have a fourth power and a second power rather than the usual second power and first power. Again, are you going to see these very often? Not really, but this helps us review the concepts from the previous class. So let's try the next problem. Again, we want y to the second power. What two numbers multiply to negative 45 and add up to negative 4? That's going to be negative 9 and positive 5. But there's one more thing that we have to do. Because in the last class, we learned that we can factor the difference of two squares. This is a difference because it's a minus sign. And it's also two squares because 9 can be written as 3 to the second power. So you have y squared and you have 3 squared. So we can continue to factor the y squared minus 9. We can make the y squared minus 9 y minus 3 and y plus 3. And we just keep the y squared plus 5. So again, y squared minus 9 became y minus 3 times y plus 3. And that is our answer because that expression is completely factored. If you left it in this form, it would not be factored completely. You always have to factor algebraic expressions completely. Sometimes it's very common for students to only go part of the way. All right, so let's try another one together. So z to the second and z to the second, and you can see we have the exact same numbers. But now we have a plus here, a plus 4. So that means it's going to be z squared plus 9 and z squared minus 5. Now in this case, we don't have the difference of two squares. Now technically we could make this a square, but you're not going to need to do that in this course. So even though we have a difference here, it can't really be factored because this is not what's called a perfect square. Perfect squares are 1, 4, 9, 25, 36, 16, so on and so forth. So, and here we have z squared plus 9, but it's not the difference of two squares, so we cannot factor this expression unless we use square roots, which we haven't learned yet, so you don't have to worry about that. All right, so let's try another one together. Again, it's a to the second. Usually it's a and a, but now it's a to the second. And negative 9 times negative 4 is positive 36. And if you add those up, negative 9 plus negative 4, you get negative 13. So again, the same type of thing we've been doing. But now we have two factors that are both the difference of two squares. So again, we learned this in the last class. You can factor the difference of two squares. So a squared minus 9 factors to a minus 3 and a plus 3. I should write those a little bigger. So we factored the a squared minus 9. And now we're going to factor the a squared minus 4. And we get a minus 2 and a plus 2. And that's our answer. So just be aware that when you factor these expressions, sometimes you're going to have the difference of two squares. So again, if you have a negative sign, then that tells you that you might be able to factor it. But you're not going to be completely sure that you're going to be able to factor it, because sometimes if you try to factor it, you'll need square roots. And we haven't learned that yet. All right, so why don't you try number 5, and when you come back, we'll do it together. All right, we're back. Again, it's going to be x to the second power, and it should be plus 7 and minus 2. Now, this is not the difference of two squares, that's the sum. This is a difference, but 2 is not a perfect square, so we can just leave that. So if you got that answer, good job. Try number 6, and when you come back, we'll do it together. All right, we're back. And it's going to be minus 4 and minus 4. Now, both of these can be factored, because number 1 is the difference of two squares, and number 2, 4 is what we call a perfect square. So we can find what two numbers multiply to 4. So we're going to need 4 sets of parentheses on this one. Again, this yellow set goes with this yellow set, and this blue set goes with this blue set, just so you know where each group of factorization is coming from. All right, try number 7, and when you come back, we'll do it together. All right, we're back. And let's see, that would be negative 1 and negative 4. So it looks like both of these factors can be factored more. So that's going to be z plus 1 and z minus 1. That's the z squared minus 1. We factored that. And then z minus 2 and z plus 2. So if you got that answer, good job. All right, try number 8, and when you come back, we'll do it together. All right, we're back. Again, we don't just need x's, we need x squared. And we cannot continue to factor that, so that should be your final answer. Some of these you can factor further, but others you cannot. So if you got that answer, good job. All right, try number 9, and when you come back, we'll do it together. All right, we're back. And it looks like we're going to have positive 4 and negative, actually no, that's not correct. It would be positive 5 and negative 1. And it looks like one of these factors can be expanded. To y minus 1 and y plus 1. Again, I just want to make it clear where each one of these is coming from. So if you got that answer, good job. All right, try number 10, and when you come back, we'll do it together. All right, we're back. And 9 is a perfect square, but it's not the difference of two squares, it's the sum. So we cannot factor that one. And we cannot factor z squared minus 2 because 2 is not a perfect square, so we'd have to use square roots, and you haven't learned those yet. We will learn square roots in this course, but not today. All right, try number 11, and when you come back, we'll do it together. All right, we're back. And let's see, I think it's going to be plus 2 and plus 6. 2 times 6 is 12, and 2 plus 6 is 8. And that's going to be the final answer. So if you got that answer, good job. Try number 12, and when you come back, we'll do it together. All right, we're back. And let's see, I think it's going to be negative 6 and negative 1. Actually, no, it's not. Let's see here. Yeah, that's not correct. Sorry about that. I think it's going to be negative 2 and negative 3. And that's going to be your final answer. So if you got that answer, good job. If at first you don't succeed, try again. And again, these are not perfect squares. Even though it is the difference here, we have a difference, they're not perfect squares, so we would just leave those. All right, try number 13, and when you come back, we'll do it together. All right, we're back. And I think it's going to be positive 9 and negative 1. And we can factor z squared minus 1. Again, the parentheses mean multiplication, so we're multiplying all these factors. That's what a factor is. It's something you're multiplying to get your product. All right, so try number 14, and when you come back, we'll do it together. Whoops, I forgot to rectangle my answer. There you go. All right, we're back. And we have negative 9 and negative 9, it looks like. So both of these can be factored because we have a difference and we have a perfect square. 9 is a perfect square. And I would use bigger perfect squares than the same 1, 4, and 9, but if you get any bigger, then it starts to become difficult to do some of the math. Let's see here. I should probably mention in problem number 6, I could have written that in condensed notation. Let me show you what condensed notation is, because in this problem we can write condensed notation also. So the x minus 3 I can actually put together, because there's two x minus 3s, I can put them together with a second power. And x plus 3 I can put them together as a second power because there's two x plus 3s. So just be aware that you may see that in your textbook when you look at the answers. In fact, it's pretty much a guarantee that you're going to see that in that form. So you should probably combine those and put them in condensed form there with the power notation. Those are called repeating factors. So why don't you try number 15, and when you come back, we'll do it together. You're definitely going to see repeating factors in number 15. So see if you can write that problem with power notation. All right, we're back. Y to the second, y to the second, minus 1, minus 1. Then we can continue to factor, so we have y minus 1 times y plus 1, and again y minus 1 times y plus 1. And if you write that in factored notation, I'm going to try to move this over a little bit. To write in factor notation, it would be y minus 1 squared times y plus 1 squared. So if you got that answer, good job. All right, try 16, and when you come back, we'll do it together. All right, we're back. I'm going to try to write a little smaller here so we can fit things in. And it's going to be z squared plus 1, z squared plus 1. I guess I didn't need to write small because you can't really do anything with that. 1 is a perfect square, but it's not the difference, it's a sum. So we can't do anything with that. So if you got that answer, good job. All right, so on to number 17. But 17, you see there's something different. These problems where you have a coefficient in front of the first term are always a pain to deal with. Because we can't just figure out what two numbers multiply to 5 and add up to 11. The multiply to 5 part works, but the add up to 11 part doesn't really work because of this coefficient. So we're going to have to ask what two numbers multiply to 5, and that would be, of course, 1 and 5. That's the only option. But we're also going to have to ask what two numbers multiply to 2, and of course that would be 2 and 1. And they're going to be plus signs, which means I think that is pretty much as far as we can go. Let's see here. So well, actually, we need to see if that's correct because it may not be correct. We have to use FOIL, the O and the I of FOIL. So outside terms would be 10x squared. And inside terms would be x squared, so I guess I got lucky on that one. The first try I did it correctly, so that was 11. If you add those together, you get 11 squared, which is what we want. All right, so let's try 18 together. So 2 pairs of parentheses as usual, and it's 3, so it's going to be 3 squared times, or excuse me, 3y squared times y squared, because 3 times 1. 3 times 1 is the only option there. And we have negative 25, so we could use 1 times negative 25, or negative 1 times positive 25, or we could use negative 5 times 5. I'm going to try negative 5 times 5. And then we have to use O and I of FOIL to see if the O and I add up to 10y squared. So outside terms would be 15y squared. Inside terms would be negative 5y squared, and I got lucky again. We got 10y squared. Now just be aware that if you end up with negative 15 and positive 5y squared, and you get a negative 10y squared, then all you have to do is just change the signs. But we did it correctly in our first try, so we don't have to worry about that. And of course, if I had chosen 1 and 25, then we would not have got the right answer. All right, so now it's time for you to try. Go ahead and attempt number 19, and when you come back, we'll do it together. All right, we're back. So 3z squared and z squared, and let's see, I'm going to try negative 4, and let's see, actually I don't think that's going to work. Well, that might work. We'll see. So let's do O and I of FOIL. So O of FOIL outside terms is negative 9z squared, or positive 9z squared. Then we have negative 4z squared, and we get 5z squared. Now this is what I was talking about. If you combine these, you get 5z squared. We don't want 5z squared. We want negative 5z squared. So all you have to do is just change these signs. Switch them around. So this would become a positive, and this over here would become a negative. And that's pretty much all we can do. So if you got that answer, good job. So why don't you try number 20, and when you come back, we'll do it together. All right, we're back. Now this problem is a little harder because now we have multiple options for 8. We can try 8 and 1, or we can try 2 and 4. I'm going to try 2 and 4. And then negative 3 times 1, that's the only option. So now we'll do O and I of FOIL. So O is outside terms is 2x squared, inside terms is negative 12x squared, and obviously if you combine those you get negative 10x squared, which is not even close. So let's try switching the 3 and the 1. So I'll put the 1 here, the 3 here. Let's try that. So outside terms would be 6x squared. Inside terms would be minus 4x squared. And you can see that that gives us 2x squared if we combine those terms, and that's what we're looking for. So now we have the correct factorization. So that was your answer for number 20. Good job. And this looks like it might be the difference between two squares, but 2 is not a perfect square, so you would need a square root for that one. So we can't factor further on that one. So try 21, and when you come back, we'll do it together. All right, we're back. And let's see, I'm going to try 3 times 3. And I'm going to try negative 4 times negative 4. Let's see here, that looks correct. Yeah, that looks correct. So now let's try O and I of FOIL. So we get negative 12 y squared and negative 12y squared, which adds to negative 24y squared. So that obviously does not work. All right, so what else can we try here? We can try 1 times 16 instead of 4 times 4. But that's not going to work with the 3's, I don't think. So it looks like we might have to try 1 and 9 instead of 3 and 3. So let's try 9y to the 4th times y, or excuse me, y to the 2nd times y to the 2nd. And then we'll try negative 4 and negative 4. Outside terms would be negative 36y squared. Inside terms would be negative 4y squared, and that doesn't give us the right answer. So that didn't work, but that's okay. Sometimes this happens. You just got to keep trying stuff. Let's see. Now let's change the 4's. Let's try 16 and positive 1. It's not very likely that it would be that, but in this problem it seems like it must be that because all right, we're running out of options here. So let's see, that all works out. Just double checking. So now let's try O and I of FOIL. So now outsides would be negative 9y squared. Inside would be negative 16y squared, which simplifies to negative 25y squared. And that's what we want. So on that one we had to try some things. If first you don't succeed, try again. But in this case, I just want you to be aware, don't go too fast here. We're not done. In this case, we actually have the difference of two squares here and the difference of two squares here. So I'm going to move this over a little bit. We're going to continue to factor. Square root, or the 3 times 3 is 9, so that would be 3y. And 4 times 4 is 16. So again, this is the difference of two squares, and you just put your plus and minus. And here, we have another difference of two squares. And there's no repeating factors, so we can't really we can't condense these into power notation. So if that was your final answer, good job. That was a hard one. So that is a special type of factoring where it looks like it's a quadratic, but you have a fourth power and a second power rather than a second power and a first power. So we're done with that. So now we're going on. The second thing we're going to do today is factoring by grouping. And once we're done with this, you'll be done with this class, and you just have to do your homework at that point. So when we're factoring by grouping, we usually have 4 terms. And you notice that you have all kinds of powers here. So this is called a polynomial. Well, we did polynomials previously, but they were trinomials. Here we have 4 terms. So this is something different. We have not done this in this course yet. But we did factor in course number 3, I believe it was. Actually, course number 4, can't remember. Actually, course number 2. And so what we're going to do is we're going to take these first 2 terms. Now, this is going to seem very strange. We haven't done this before. You're going to take these first 2 terms and you're going to factor out the greatest common factor. Now, again, we did this in class, I don't know what class number we did. Actually, now that I think of it, it wasn't class 2. Class 3, class 4, something like that. So we've done this already. We know to factor out the smallest power, which is x to the 2nd power. And we're left with x plus 4 inside. Now, if you don't understand why that is, it's really easy to figure out why that's true. You just use the distribution rule and you multiply back, and you get x cubed times or plus 4x squared. So again, we just factored out the greatest common factor of the first 2 terms. Now we're going to go to the second 2 terms. So I want to color code this just to make sure you know exactly what's going on here. And we're going to go to the second 2 terms. And we have, now we're going to factor out the greatest common factor of these 2 terms. And the greatest common factor is 4. So again, this is called factoring by grouping. So we factored the first group and the second group, and that's why it's called factoring by grouping, is because you're factoring each group separately. But now there's something really, really important to understand about this expression. We have a common factor. We have x to the 4th here, and we have x to the 4th here. Do you see that? X to the 4th here and x to the 4th here. There's 2 x to the 4th. So what we can do is we can factor out that x to the 4th. Or am I saying x to the 4th? I mean x plus 4. Sorry. And x to the x plus 4 and x plus 4. Factor that out. So we're taking this out and we're taking this out and we're putting it here. You understand that? We're taking this out, this x plus 4 and this x plus 4, and we're putting it in front. We're factoring it out. And then you're left with x squared plus 4. This can be very intimidating if you don't see exactly what's going on here. And so now we're done. That's the factored form. If we had x squared minus 4, we wouldn't be done, because that would be the difference of 2 squares, because 4 is a perfect square. But since we have sums, we know we're done. So that is factoring by grouping. Again, this can be intimidating if you've never seen this, but that's okay, because we're going to do quite a few more problems. All right, so again, we're going to take the first 2 terms, and we're going to factor out the greatest common factor. So 2 goes into both 6 and 10, so I know I'm going to pull out 2. And y to the 2nd power is the smallest variable power, so we're going to pull that out. And then I just have to figure out what's left inside. So 2y to the 2nd power times what is equal to 6y to the 3rd power. Well, 2 times 3 is 6, and y to the 2nd times y is y to the 3rd. Now 2y to the 2nd power times what equals negative 10y to the 2nd power. So 2 times what equals 10? Well, obviously it's negative 5. And y to the 2nd times how many y's is y to the 2nd? Well, that would just be, there's no y's there. So again, I know that's kind of confusing, but all I did is just factor out the greatest common factor from these first 2 terms. So now we're going to go to the second group, and the greatest common factor is 3. And you're left with 3y minus 5. Whoops. So you want to check that by multiplying back. 3 times 3y is 9y, And 3 times negative 5 is negative 15, so that works. All right, so now you're probably noticing what's going on here. We have 3y minus 5 in both of these. So we can pull that 3y minus 5 out, and you're left with the 2y squared and the 3. So 2y squared plus 3, and then you're done, because we can't factor any further. We don't see any difference of 2 squares. All right, let's do some more of these together. Again, this is a concept that's not very pleasant to have to learn. So in the first 2 terms, we're going to have to factor out the z to the 4th. That's the greatest common factor. And z to the 4th times what is equal to z to the 5th? Well, obviously that's just z. And then the second term is going to be negative 1, because z to the 4th times negative 1 is negative z to the 4th. So we factored out the greatest common factor from the first 2 terms. I'm going to use a different color here. Now maybe I should just use the same colors. I don't want to confuse. All right, so now we're going to do, now this is something that is a little bit different here. Because in the second terms, and this is something that's going to confuse a lot of students. In the second 2 terms, we're going to have to multiply, or we're going to have to factor out a negative. So we're going to factor out negative 81. And what that's going to do is it's going to change the signs. This term is negative, but now it becomes positive. And this term is positive, but now it becomes negative. So just be aware that's a huge potential source of error when you're doing these problems. Sometimes you have to factor out a negative. Be aware of that. All right, so let me color code these, and you see what's going on here. We have z minus 1 and z minus 1. So that's a common factor, and we're going to factor out the z minus 1, and then you're left with z to the 4th minus 81. Z to the 4th minus 81. And we've got a special circumstance here. This is something that we didn't go over very much, but I just want you to be aware that you might see this. This is the difference of 2 squares. It doesn't look like the difference of 2 squares, but it is. Because technically this is a perfect square and this is a perfect square. Because that would be z to the 2nd power and z to the 2nd power. Now we don't see those very often when we're dealing with difference of 2 squares, but if you have an even power here, it's always the potential to be a difference of 2 squares, because you might have z to the 6th minus 81. Then you would have z to the 3rd and z to the 3rd. Because z to the 3rd times z to the 3rd is z to the 6th. Also, if you have z to the 8th, that might become z to the 4th times z to the 4th, so on and so forth. Again, I'm not going to give you very many of those problems, but I just want you to be aware that you might see those. We don't have time to do every single variation of these problems, especially if they're not really seen very commonly, and I really haven't seen this much in textbooks, so you don't really need to worry about that too much. All right, so this is going to be minus 9 and plus 9, but we've got more problems here because this is a perfect square also. So we have to continue to factor that. So let me double check all that. It looks correct. So now I'm going to have to continue to factor z squared minus 9, so that would be z minus 3 and z plus 3. And thankfully we don't have any repeating factors, so we don't have to combine anything. So that would be the final answer. So that one was kind of a challenge problem. So why don't you try number 25, and when you come back, we'll do it together. All right, we're back. And on this one, I noticed that we have to factor out a negative, so hopefully you got that. See, we had to factor out the negative 9. Students really don't like that. They don't like having to factor out that negative 9. The notation is very confusing, but you're going to have to get used to it. And you can just multiply back to check your answers to make sure that it's correct. X squared times x is x cubed. X squared times negative 5 is negative 5x squared. And negative 9 times x is negative 9x. And negative 9 times negative 5 is positive 45. So now we have an x minus 5 that's common. It's a common factor, so we can pull that out. And we're left with x squared and minus 9. But you may have noticed that we can continue to factor that because x squared minus 9 is a difference of 2 squares. So that would be our final answer. So if you rectangle this as your final answer, you're not wrong. It's just that you have to continue to factor. So if you got that answer, good job. Now let's do number 26 together because something strange is going to happen. So we'll factor out the greatest common factor from the first two terms, and that would be 6y cubed. And on the second two terms, there's nothing to factor out. That's what's strange about this problem. There's really nothing you can do here, so you just have to leave it. But at that point, it seems kind of confusing. Well, what do we do at this point? What do we do here? Well, you know, what's going on? Well, what's going on is, let me move this over a little bit. If we write parentheses around this and write a 1 here, then you can see what's going on. Then it looks like the same problems that we did before. So you don't really have to put a 1 there, but just to show you what's going on, I'm going to do that. So we have a common term, 2y minus 1. And so you're going to factor out the 2y minus 1. And you're going to be left with 6y cubed plus 1. So just be aware that that's a huge source of confusion for students when you see something like that. You're going to see, you're not going to see what I wrote here. You're just going to see 2 minus 1 with no parentheses because there's really nothing that you can factor there. So that's a potential source of confusion. So you need to be really, really aware of that. Number one, there's a source of confusion when you factor out a negative. And number two, there's a confusion where you have a factor of 1. All right, so try number 27. You're going to have the same situation for number 27. And when you come back, we'll do it together. All right, we're back. So I'm going to factor out the greatest common factor in the first two terms. So that would be 4x squared. And you're left with 5x plus 3. And over here, there's really nothing to factor. So you can just consider it to be 1 times 5x plus 3. And if I didn't make it clear before, again, if you use the distribution rule, and you distribute that, then you're just going to get the same thing, 5x plus 1, and that's what we want. But we put the 1 here with parentheses just so you can see that 5x plus 3 is a factor for both of these terms. So now we're going to factor out the 5x plus 3. And we end up with 4x squared plus 1. So that's the final answer. So if you got that answer, good job. All right, on to number 28. So go ahead and try 28, and when you come back, we'll do it together. All right, we're back, so I'm going to factor out in the first two terms. And the second two terms. And then we have x minus 3 times x squared minus 4. And now we have the difference of two squares, so just be aware of that. We can factor those. And that would be the final answer. So if you got that answer, good job. All right, so let's do number 29 together because something different is going to happen here. factored out the greatest common factor for the first two terms. But now here, if we just leave it as negative 7 plus z, we don't really have a common factor. Let's see, we could factor out a positive 1 like we did in the previous problems. But again, you can see we don't have a common factor. Negative z plus 7 is not the same thing as z minus 7. So we're going to have to try a trick here. It's called the negative 1 rule. We're just going to factor out negative 1. And what that's going to do is it's going to change the sign. So now it becomes z minus 7. So again, if that's really confusing to you, all you have to do is just multiply this negative 7 back using the distributive rule, and you can see that it becomes negative 7 plus, negative z plus 7. So now we see we have the common factors. So again, these are potential sources of problems for students. So factor out the z minus 7, and we're left with 5z squared minus 1. So I want you to try one of those problems. Try number 30, and when you come back, we'll do it together. All right, we're back. So I'm going to factor out x squared from the first two terms. And then here, we have to factor out a negative 1. And so now we have x minus 2 is a common factor. We factor out the x minus 2, and we have x squared minus 1. But we're not quite done, so we've got to keep going here. X squared minus 1 becomes x minus 1 times x plus 1. So if you got that answer, good job. And number 31 is another example of that type of problem. So why don't you try 31, and when you come back, we'll do it together. All right, we're back. So I'm going to factor out 2z to the 5th. And I'm going to factor out a negative 1 like we did before. And again, you can see we have common factors. And by the way, if you factor and you don't see a common factor here, you know you must have done it incorrectly. Or if you try to use factoring by grouping in other problems and we don't have a common factor, then you know we really can't use factoring by grouping. It doesn't always work. But in my problems in this class, it'll work. So factor out the z minus 9. And then we're left with 2z to the 5th minus 1. So if you got that answer, good job. All right, on to number 32. We have another example of this type of problem. So try 32, and when you come back, we'll do it together. All right, we're back. And we have x squared minus 1, so we can keep going with that. We have x plus 1 and x minus 1. So if you got that answer, good job. So let's do number 33 together. We're going to factor out 4y squared. And then we're going to factor out a negative 1 from the next two terms. And again, if you don't understand how I did that, you can just distribute, and you get negative y minus 3. So now y plus 3 times y, 4y to the second power minus 1. And I see actually this is a perfect square, so we can continue with that. That becomes 2y minus 1 times 2y plus 1. And that would be the final answer. So why don't you try 34, and when you come back, we'll do it together. All right, we're back. Factor out a -1. And you can see that we have common factors, z plus 4s. So z plus 4 times z to the 4th minus 1. And now z to the 4th minus 1, that's kind of a special case where we can factor quite a bit. So we're going to have to be sure to write small here. That would be z squared minus 1 times z squared plus 1. But z squared minus 1 is the difference of two squares, so we can keep going with that. So that would be z plus 4 times z minus 1 times z plus 1, z squared plus 1. So I want to make this easy for you. So I can color code this. So that's what's going on there. So that was your final answer. Good job. That was a tough one. Alright, so I'm going to write equals down here because I'm running out of room. Actually, let me just move that up. Try 35, and when you come back, we'll do it together. Alright, we're back. So this is going to be a squared 5a minus 4, and pull out a 7, and we get 5a minus 4. Now again, we need that 5a minus 4, or else it's not going to work. So distribute back and make sure that we did that correctly. And we did. And we can factor out a 5a minus 4, and then we get a squared plus 7, and rectangle, and we're done. So if you got that answer, good job. All right, try number 36, and when you come back, we'll do it together. All right, we're back. Factoring out a -4. And now we can factor out an x plus 10. But we're not done because we have the difference of two squares here, so we can continue to factor. X plus 10 times x minus 2 times x plus 2. And we're done. So if you got that answer, good job. All right, on to number 37. We're almost done here. If you made it this far, you're doing good. So go ahead and try number 37, and when you come back, we'll do it together. All right, we're back. You're going to have to factor out a negative on the second pair. And I just noticed that that's not one of our multiplication facts, but you should be able to figure out that 3 times 15 is 45. Everything looks correct, so we factor out the x minus 15. And we're left with x squared minus 3. So we got that answer. Good job. Now again, this is the difference of two squares technically, but that's not really a perfect square, so we don't have to deal with that. All right, try number 38, and when you come back, we'll do it together. All right, we're back. Whoops. Factor out the -9. And again, you should get the x plus 4. You should get a common binomial here. If you're not getting common binomials, that means that you're not doing something right with the sign, or you're not factoring correctly in some way. So let's double check. Multiply back, see if we got everything correct. Looks correct. Factor out the x plus 4, and we have 4x squared minus 9. But unfortunately, we can continue with this because that's the difference between two squares. So now we keep going. We can actually go down this time because we got room. X plus 4, and then this becomes 2x minus 3 and 2x plus 3. And again, we learned that in the last class. So if you're complaining that you don't understand how I'm going from here to here, that probably means you didn't do the homework from the last class. Again, 2 times 2 is 4, and 3 times 3 is 9. So that's where we got the 2 and the 3. All right, so if you got that answer, good job. So that was the class today. Again, we just did two things. We did this special type of quadratic where you have a fourth power and a second power. And then we did, and again, the only difference is you have squared terms here. Instead of y times y, it's y squared times y squared. And we also did factoring by grouping. So this is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that. But don't go before you get your homework. Here's the homework. Get screenshots of the first 2 pages here. And the 3rd and 4th page. We have the answers here. So remember, if you don't do the homework in this class, then you're just not going to learn fluency, and that's the primary objective of the course. So be sure to get that homework done completely, correctly, neatly, and keep it in order in your binder. And I'll look forward to seeing you in the next class.